You've probably heard about the vastness of the universe. Imagine this: 7.5 billion people. In your entire lifetime, you'll only meet about 10,000 of them. At any given time, you're in touch with just 100 to 120. If you tried to count to 7.5 billion, it would take you 237 years of non-stop counting, day and night. Now, imagine squeezing all those people into a space of just 27 square kilometers. That's how vast our world is. But when compared to the solar system, Earth is an almost insignificant speck. For instance, you could fit 1.3 million Earths inside the Sun. That's how immense the Sun is. Yet, the Sun itself is nothing but a tiny in the Milky Way galaxy, which is home to 200 to 400 billion stars, each possibly surrounded by its own planets. It's estimated that there could be 40 billion Earth-like planets in the Milky Way alone. But even our entire galaxy is just a drop in the ocean of the observable universe. The observable universe contains about 225 billion galaxies similar to ours. And if we include dwarf galaxies, the observable universe is home to trillions of galaxies. So, within this massive expanse, you are one of the billions of people living on one of the billions of planets in one of the billions of star systems in one of the billions of galaxies. But why limit ourselves to the observable universe? What about the universe beyond our observation? How large could that be? In this video, we'll dive into the concept of the observable universe and explore what it tells us about the true scale of existence. If you're a fan of popular science, you've probably heard of the term observable universe. This term refers to the sphere of the universe that you could theoretically observe from any point, determined by the farthest distances light has traveled to reach us. According to the latest estimates, the universe is 13.82 billion years old. So, if your eyes were perfect and you had a telescope with infinite power, you could see light from up to 13.82 billion light-years away. But what lies beyond that? Nothing but darkness. Because nothing in the universe can travel faster than the speed of light, no light or photons can reach us from beyond that distance. Does this mean the universe is only 13.82 billion light-years in radius? Not at all. That's just the radius of the observable universe. And this radius changes depending on where you are in the universe. For example, from Earth, we can see a sphere with a radius of 13.82 billion light-years. But if you were in the Andromeda galaxy, 2.5 million light-years away from us, your observable universe would have a slightly different center, separated from ours by 2.5 million light-years. So, technically, our observable universe and that of the hypothetical green aliens in Andromeda wouldn't be exactly the same. They would overlap significantly, but there would be a 23 billion kilometer difference between their centers. This means that each of us is at the center of our own observable universe. However, this is a bit of an illusion. We're not at the center of the universe itself, just the center of the part we can observe. Interestingly, we know that the universe's actual size is far larger than the 13.82 billion light-years of our observable universe. This is because the universe has been expanding ever since the Big Bang. So, the actual diameter of the observable universe is around 93 billion light-years. Think of it this way. If you were driving from New York to Los Angeles, a trip that normally takes about 41 hours, imagine the road stretching as you drive, so the journey ends up taking 100 hours. In the same way, the light we see from the edge of the observable universe has traveled across an ever-expanding space, making the observable universe much larger than just 13.82 billion light-years. 93 billion light-years. A light-year is roughly 9.5 trillion kilometers. So, the distance from one edge of the observable universe to the other is almost 1 quadrillion kilometers. Now, I'm throwing out these huge numbers, but for most people, it will probably go in one ear and out the other. And it's our too. How big is the universe beyond the observable universe? This has puzzled physicists for a long time. We know that the universe is larger than what we can observe. But how much larger? Moreover, our observable universe is a sphere. But what is the actual shape of the universe? Is it spherical? Is it curved like a saddle? Or is it flat? For simplicity's sake, let's assume it's a sphere for now. However, I must tell you, the universe is probably not a sphere. We'll discuss its shape in detail in another video. Another question we must ask is, could the universe be infinite? In physics, We're not very fond of the concept of infinity because it's hard to imagine something without an end in the physical world. An infinite universe would have some very strange properties. For example, if the universe is truly infinite, somewhere out there, this video is playing again, but this time you're the one talking, and I'm listening. If the universe were infinite, these kinds of oddities would have to exist. But what if the universe isn't infinite but still unbounded? Because that's possible. For instance, you currently live on a planet that is not infinite but is unbounded. This might sound strange at first, but we live on a surface that is effectively unbounded. Because Earth is spherical, in the two-dimensional plane of north-south, east-west, no matter which direction you go, you remain within the Earth's boundaries. This means that in this plane, we can move indefinitely without ever reaching the edge of the Earth. If you keep traveling east, you'll never reach the end of the world. So, Earth is effectively unbounded for us. However, when we move into the third dimension, going upward, we can leave the Earth's boundaries. The universe could be a similar structure, unbounded in 3 dimensions. To exit it, we might need a 4th dimension. Even though the Earth is unbounded in 2 dimensions, we know it has a finite surface area, about 510 million square kilometers. Is it possible to know a similar number for the universe? Partially. According to the cosmic inflation theory proposed by Alan Guth, we know that the universe started expanding extremely rapidly after a time as small as 1/trillionth of a trillionth of a trillionth of a second after the Big Bang. Before this rapid expansion, the universe is thought to have been expanding at the speed of light. Based on this information, one calculation suggests that the radius of the universe could be at least 300 trillion quadrillion times larger than the radius of our observable universe. And that's the minimum. Of course, different calculations yield different results. In one academic source I found, the lowest estimate for how much larger the universe is compared to the observable universe was about 250 times. But this doesn't seem to be widely accepted. This raises the intriguing question, how large could the universe possibly be? According to a calculation by Don Page from the University of Alberta's Institute for Theoretical Physics, the diameter of the universe could be 10^10^10^122 megaparsecs. I'm laughing because it's hard to even convey what that means. Let me try. So, think about it. What does 10 to the power of 10 mean? It means adding 10 zeros after the number 1, so 10 billion. What about 10^10^10? That means 10 to the power of 10 billion, or adding 10 billion zeros after 1. Now, 10^10^10^122 means you take that number with 122 zeros and repeat the process over and over. This incredibly huge number gives us the size of the universe in megaparsecs. And just 1 megaparsec equals 30 billion trillion kilometers. Mind-blowing, isn't it? 3,750 million. Billion. Which of these calculations reflects reality? We don't know yet. But why does such a vast, seemingly incomprehensible universe exist? What's inside it? And what lies beyond? These are questions that have fascinated scientists and philosophers for millennia, and rightly so. If we want to reach what we call truth, we must understand this structure and what it contains. To do that, we need to learn more about science and analytical philosophy, use our tools for discovering truth more efficiently, and produce more science and philosophy, especially in our country.